In this exercise, the task is to print the numbers from 1 to 100, but with some special conditions. For numbers that are multiples of 3, instead of the number, you should print the word fizz. If the number is a multiple of 5, you will print the word buzz. However, for numbers that are multiples of both 3 and 5, you will print fizzbuzz. This means you are checking each number to see if it fits one of these conditions, and then deciding what to print based on that. So the goal is to recognize patterns in the numbers and replace them with the correct output. The rest of the numbers will just be printed normally. Good, so here we define a function called fizzbuzz. The function does not need a parameter because it's specifically designed to work with a fixed range of number from 1 to 100, and in this case the function already knows what range to iterate over from 1 to 100, so no external input is required. And inside the function we have the logic to print the numbers or words like fizz or buzz. This for loop iterates over a sequence of numbers from 1 to 100, and this function range generates numbers starting from 1 up to, but not including 101. So practically the loop runs from 1 to 100. During each iteration within the loop, the variable I takes the value of the current number in the sequence. So within the for loop, with an if statement, we check if that current number is divisible by both 3 and 5. And if it's true, we print the word fizzbuzz because the number satisfies both conditions. Then in the second block, we check if the number is divisible only by 3, and if it's true, we print only fizz. And then finally we check if the number is only divisible by 5, and in that case we print buzz. And then else, with this else statement, if none of the conditions are met, meaning the number is not divisible by either 3 or 5, it just prints the number itself. And finally the function is called with fizzbuzz, fizzbuzz, which executes the logic for all numbers from 1 to 100. So let's run the function. So when that fizzbuzz function is called, it prints a sequence of numbers from 1 to 100 with specific substitutions based on divisibility. For numbers divisible by both 3 and 5, it prints fizzbuzz, and these numbers like 15, 30 or 45, for example, represents a common multiple. For numbers only divisible by 3, such as 3, 6, 9, it prints just fizz, indicating their relationship to 3, right? And similarly, for numbers divisible only by 5, like 5, 10, 20, it prints buzz. and all other numbers that are not divisible by either 3 or 5 are printed as they are. Alright, showcasing the complete range from 1 to 100. This method creates a fun and engaging output where every multiple of 3 and 5 is highlighted, and the result visually represents the pattern of number. So in this exercise we have to create a function that calculates the total number of points a basketball team has based on the number of wins, draws, and losses. The rules for calculating the points are wins. Each win gives 2 points. Each draw 1 point, and each loss 0 points. Alright? So this function takes 3 parameters: wins, draws, and losses, and then directly in the return statement we calculate the total points based on the number of wins, draws, and losses. And then we simply multiply the number of wins by 3 here, by 2, not 3, by 2, because each win earns 2 points, and then the draw by 1 and losses by 0. So here, for example, when we call this function, we give as a parameter 3, 4, and 2, which means the team won 3 times, drawn 4 times, and lost 2 times. So based on these parameters, then we should calculate the total points. So now let's run the function. Alright, so in this exercise we should create a function that checks whether a given number is divisible by 5. So the function will take one parameter and will return a boolean value, true or false. Alright, so the function takes one argument, that is the number we have to check. And then we use an if statement to check if the number is divisible by 5. And for that we use this module operator that calculates the remainder of the division of one number by another. So here we calculate the remainder when the number we pass as a parameter is divided by 5. And this condition checks whether the result of this operation is equal to 0. And if the remainder is 0, it means that this number we pass as a parameter can be divided evenly by 5. Therefore, the condition evaluates to true, and otherwise it's false. Remember, in Python the boolean values are written with an initial capital letter. This is different from some other programming languages where boolean values may be written in lowercase. So in the first case, if 10 is divided by 5, this condition will be equal to true, because 10 divided by 5 is equal to 2. but in this case with 7. It's false, because 7 divided by 5 is 1 with a remainder of 2. Alright, so now let's check the function, and the results are as expected. In this exercise we need to check if the 15th day of a given month and year falls on Wednesday. Alright, so in Python, to work with dates and times, you need to use the datetime module, which must be imported at the beginning of your code. This is necessary because Python does not include all date handling functions and classes by default, unlike JavaScript, where functionalities for working with dates are built into the date object and don't require any additional imports. So the function takes two parameters, month and year, so that the function can determine if the 15th day of that specific month and year is a Wednesday. And then in the return statement, everything is defined directly. With this datetime.date, we create a date object for the 15th day for the given month and year, which are the month and year that we passed then as parameter. And then the method weekday returns the day of the week as a number, where Monday is 0, Tuesday is 1, and so on. And for Wednesday the number is 2. So this equal to 2 checks if the 15th of the given month and year falls on Wednesday. So let's see what we get if we run the function. Instead of true, here is false. My mistake. In this function, we will try to determine if a given year is a leap year. So the function should check if the year meets the condition for being a leap year. And if these conditions are met, the function will return true, indicating it's a leap year, otherwise it will return false. Alright, so the function takes one parameter, which is the year, to be checked. And within the function, we simply evaluate the conditions that determine if a year is a leap year. And the first condition is the year must be divisible by 4. So it is if the year is not divisible by 4, it's directly not a leap year. So that's the most important condition. And then if the year is divisible by 4, we have to verify if it's also divisible by 100. And if that's the case, if it's divisible by 100, it's not a leap year, unless it meets the other condition. If the year is divisible by 100, then it should be divisible by 400 to be considered a leap year. For example, our first year, this one, is divisible by 4 and not by 100, so it's a leap year. The second case, it's divisible by 100 but not by 400, so it's not a leap year. Third case is divisible by 400, so it's a leap year. And the last case, 2023, is directly not divisible by 4, so it's not a leap year. So let's run the function, and we get the results here as expected. In this function we should print all even numbers from 1 to n. N is the parameter, it's the number we pass as a parameter, which allows us to specify the limit when calling the function. So the function starts by initializing a variable I to the value 1, and this variable will be used to iterate through all numbers from 1 to n. Then we use a while loop that ensures that the function continues to execute as long as I is less than or equal to n. And this is the condition that controls the range of numbers the function checks. So the loop runs repeatedly, increasing I by 1 in each iteration until it reaches n. And inside the loop we set a condition that checks if the current value of I is an even number. This modulus operator returns the remainder of the division of I by 2, and if the remainder is 0, it means that I is divisible by 2, and therefore it's an even number. And if this condition is true, the function will print the value of I. This means that only even numbers will be printed. And after each iteration, this statement will increase the value of I by 1 to move to the next number, and then the loop will repeat the process. Now let's try the function. And as a parameter, as n, will pass, for example, 30. Let's run the function, and we have all the even numbers up until 30. Alright, so in this exercise we should determine if the word is plural or not. And for that, the function should check if the word ends with the letter S. Right, so first we make sure the word is not empty. This prevents errors when checking the last character of the word. And then the function checks if the last character of the word is S using this expression. Remember, with -1 we access the last character of a string, and then if the last character is S, we return true, indicating the word is plural. Otherwise we return false. Let's run it. Alright, so here we see how the function distinguishes between plural and singular words based on their last character. Good, so in this exercise we should write a function that counts the number of digits in a given number, and in this example the function should return 9 because this number consists of 9 digits. So for that we will start with our function. So this function takes a number as a parameter. The function starts by initializing a variable counter to 0. This variable will keep track of the number of digits. Then we convert this variable number to a string, because in Python converting a number to a string is necessary in this function, because when counting individual digits we need to treat the number as a sequence of characters. In Python, numbers are not iterable. They don't support looping through their digits directly. So by converting the number to a string, we can easily iterate through each character. And then to iterate over each character, we use this for loop. In Python, this underscore is used as a convention when the loop variable is not actually needed inside the loop. Normally, when you use a for loop, you define a variable to represent each element being iterated over, but however, in this case, the loop is simply counting the digits. Therefore, we don't need to reference each individual digits. And then inside the loop, for each character that we are iterating over, we increment the counter by 1. And after the loop finished, the function returns the final count of digits stored in counter. Alright. Let's see now if the result matches our expectations. Run it. It's 9. Great. And now let's see an easier or shorter way to solve this exercise. And what makes this function simpler is that it avoids using loops or complex logic to count the digits, instead of iterating through each digit manually. This function uses Python built-in len function. This native function directly counts the number of characters in the string representation of the number. So let's add one number more. It should return 10 and it returns 10. In this exercise we should create a function that generates the multiplication table for a given number. It would be a multiplication table from 1 to 10 for any number you provide as input. Alright, so first we initialize an empty list named result. This is done to prepare for adding elements to the list, and it will get filled with the multiplication results as the loop iterates. And then we use a for loop to go through numbers from 1 to 10. This expression in range is part of the loop, and it generates a sequence of numbers from 1 to 10. It starts at 1 and goes up to 11, but it does not include that number 11. So the for loop will iterate through each of these numbers in sequence. The loop will stop when it reaches 10 because 11 is not included. Then this line constructs a string that represents the multiplication of n by I and stores it in the result list. This is a formatting string, an F string, which is a way to format strings in Python. It allows you to embed expressions inside string literals using curly braces. And n and I are the variables. N represents the integer for which you are generating the multiplication table, and I represents the current multiplier in the loop. And then we use the append method that is used to add the formatted strings to the result list. Append is a list method that adds an item to the end of the list. Here we are basically combining a mathematical operation and a string manipulation to create a user-friendly output for the multiplication table. And finally, with the join method, we concatenate all elements into a single string using, in this case, this separator. So let's print the result. For example, multiplication table of number 5. And here we have the result. Another way to do it, much more simpler, would be and this version is much more simpler because we directly print the multiplication table to the console, line by line, as the loop runs. So there is no return value. The function does not return any value. It simply outputs the results using the print function. But it's not reusable because since it does not return the result, you cannot easily use the table for further processing or storage. Let's display the result straight with another number. Alright, so this exercise asks you to create a function that identifies prime numbers from a given list of integers. Remember, a prime number is a number greater than 1 that has no divisors other than 1 and itself. So the function should identify those numbers, right? Alright, so in the code there are two separate functions that work together to achieve the goal of filtering the prime numbers from the list. And the first one is a helper function that determines if a number n is prime, and that's why it takes n number as a parameter, and then with this if statement evaluates if any number less than 2 is not prime, so the function immediately returns false for such numbers. And then the for loop checks if that number has any divisor other than 1 and itself. It iterates from 2 up to the square root of n. And if any divisor is found, it returns false, indicating the number is not prime. And if no divisors are found, it returns true, meaning the number is prime. And then we jump to the main function that processes the list of numbers, and it uses isPrime function to check each number in the list and returns a new list that only contains the numbers from the original list that are prime. Alright, let's run it. And here we have the prime numbers. In this exercise, we should create a function that converts a binary number composed of zeros and 1, as we see here, into its decimal equivalent. It will work by taking the binary number and extracting each digit from right to left. And for each digit, it multiplies the digit by 2 raised to the power of its position in the binary number. Let's see how it works. So remember, a binary number is a number expressed in the base -2 numerical system, which use only 2 digits, 0 and 1. Binary numbers are the foundation of computer systems, as they are used to represent data in digital devices where only 2 states, on and off, are possible, right? So as the initialization, we have 2 variables, decimal and I, which both are set to 0. Decimal will store the final decimal result, and I is the variable that tracks the position of the binary digit from right to left. Then we set a while loop which continues until the binary number becomes 0. And within the while loop, we extract the last digit from the binary number using the modules operator. Because when you divide a number by 10, the remainder is the last digit of that number. This is true for both decimal and binary numbers. So if the binary number, for example, is this number, and you divide it by 10, the result will be 1, which is the last digit, alright? And then in this line we convert the binary digit into its decimal equivalent. So remember, check in this variable is a current binary digit, either 0 or 1. And here we calculate 2 raised to the power of I, where I is the position of the binary digit starting from 0. And here we give the decimal value of the current binary digit. And that value then is added to decimal, which accumulates the total decimal value as the loop process each binary digit from right to left. So let's check our function. And our result matches our expectations. So in this function we have to determine which number is missing. If you look at this list of numbers, you can easily spot which number is missing just by observing the sequence. But the challenge is now to do it through a function. Right, so the function takes two parameters, the array of integers, which contains the actual numbers that are present in the sequence. It allows the function to analyze which numbers are included and identify the one that is missing, and then n, the integer n. This parameter represents the highest number in the complete sequence, which is essential for calculating the expected sum of all numbers in that range. Without these parameters, the function would not know the complete set of numbers to compare against. And then we calculate the expected sum, which computes the expected sum of the first n natural number using the formula of this expected sum, which is this one. This formula calculates the total sum of all integers from 1 to n. The numbers from 1 to n constitutes an arithmetic series where the first term is 1, the last term is n, and the numbers of terms is n. So this formula is important for finding the missing number in a list of integers, because it provides the total that should be present if no numbers were missing. So by comparing this expected total with the actual sum of the numbers in the provided list, we can easily determine which number is not present. And then we calculate the actual sum of the numbers present in the input array, and then we determine the missing number by subtracting the actual sum from the expected sum that we calculated with the formula. And in that way we find the missing number. If the input array includes all the numbers from 1 to n except 1, this difference will reveal the missing integer, and then we'll return the missing number. So let's try this function. And as you see, in the first case it's missing number 3, and the second case number 2. Alright, so this exercise involves creating a function that takes a list and moves all the occurrence of a specific element to the end, while keeping the order of the other elements unchanged. So if the specific element here is 1, we should move all the occurrence of 1 to the end, and the result would be here the number 1 twice at the end. Alright, so the function has two parameters, the list of elements and the specific element to be moved to the end. Then we initialize an empty list called result that will hold the items that are not the specific element, and then the count variable to track how many times the element appears. Then we iterate through the list with a for loop, and if the current item is equal to the specified element, then the count the counter variable is increased, and if it is not equal, the item is added to the result list. And then with this line we add a specific element to the result list multiple times based on the value of count. We create a new list that contains the element repeated count times. For example, if the element is 1 and the count is 3, the expression will evaluate to 1, 1, and 1. And the extend method is called to add all the elements from the newly created list to the end of the result list. Now you see the output matches the result we're looking for. So in this exercise we should implement a function that counts how many times the word bananas appears in a string. Let's focus on the first alternative. So we pass a string as parameter that represents what we are interested to analyze, and then we initialize a counter, a variable called count, to keep track of the occurrence, and an index to search through the string. Then we use a while loop to continuously search for the substring bananas using the find method. At the beginning of the while loop, we use this expression, which is a condition used in a loop to ensure that the search continues as long as the index variable is less than the length of the string. So this length string is the function that returns the total number of characters in the string. It is used to determine the upper limit for the index variable. And the index variable is used to track the current position in the string where the function is searching for the substring bananas. Initially, index is set to 0, indicating the start of the string. So suppose we have this string banana, banana, and we are searching for the substring banana. The loop starts with index 0, and as the loop progresses and finds banana, it increments the index by the length of banana, which is 6. This will continue until the loop checks positions that are valid, and once index reaches or exceeds the length of the string, the condition index less than the length of the string becomes false, leading the loop to stop. So within the while loop, with this find method, we look for the first occurrence of the substring banana starting at position index in the string, and if this substring is found, this find method returns the index position where banana starts in the string. If banana is not found, the find method returns -1. And then here is where we check if index is equal to -1, which indicates the substring banana was not found. And if that's the case, it means there are there are no more occurrence of banana in the string. Therefore, break. Break because this condition is true. So the break statement is executed, which immediately exits the loop. But if the loop hasn't been exited, this line increments the count variable by 1, which means that a new occurrence of banana has been found. So count keeps track of how many times the substring has appeared in the string. But to clarify, let's put it in an example. If I have this string, I like banana and banana bread. The index might find banana starting at position 7, right? And the count is incremented to 1. And the index is updated to 13, which is the position right after the first banana. In the second iteration, the index finds banana starting at position 17, alright? And the count is incremented to 2. And then the index is updated to 23. But in the third iteration, the index is set to find banana started at position 23, but it returns -1 because there are no more occurrence, and the loop exits because of the break statement. And the final result count will be 2, indicating that banana was found twice in the string. So now let's try our function. Here we have 1, 2 and 1. And now let's try it with a simpler way. And this approach is much more simple because we use a native Python function. This method count is a native Python method of string objects, which is an efficient way to determine how many times the substring banana appears. We can run it and we get the same result. But anyway, it's important to understand both more programmatic approaches and simpler built-in method when writing functions in Python. Understanding both styles is very valuable. You as developers grow more comfortable with programming where you can arrive to solutions that use both approaches. In this exercise, we need to create a function that removes the letters x, I, and z from a given string. If none of those letters are found, the function should return none. Otherwise, it should return the string with those letters removed. Right, so the function takes one argument, which is expected to be a string. And then in this line with this conditional, we check if any of the chapter x, I, z are present in the string. If at least one of these chapters exists, the condition evaluates to true, and the code inside this if statement will execute. This if in Python is used to check if a value exists within an iterable, like a list, string, or tuple. It's like the include method in JavaScript. So then if the condition is true, this line removes all occurrence of x, I, and z from the string using the replace method. The replace method takes two arguments. The first is the substring to be replaced, in this case x, I, and z. And the second is the string to replace it with, in this case an empty string. If none of those characters are found, then we return no. In that case, the input string would remain unchanged. So let's run the function. And as you see here, it removes the x and this x, I, z, and it's working fine. Another approach to resolve this exercise would be so this function performs the same task, but instead it uses Python filter function for a more functional programming approach. Here the filter function applies a lambda function to each character in the string, and the lambda checks whether each character is not in this string. And then the join method combines the characters that pass the filter back into a single string. So let's run it, and we get the same result. In this exercise, we need to create a function that takes a string and returns it in reverse order. So we initialize this char list to store characters temporarily. Then we iterate over each character in the input string. And for each character, we insert it at the beginning of the char list using this method insert. This insert method is used with list to add an element at a specified position. The first parameter is the position in the list where you want to insert the new element. If you specify in this case 0, it means you want the element to be added at the beginning of the list, and then the element you want to add, in this case the current item we are iterating over. And after the loop completes, the join method is used to concatenate all characters in this char list into a single string. So now let's run the function to see what we get in return. Alright, let's try with another approach. Here we are using a more traditional approach. This string is reversed by iterating through each character one by one. The for loop iterates over each character, and for each character it constructs the reversed string by adding the current character in front of. So in this approach we are simply building the reversed string character by character. If you run it, the result is the same. There's still a much more simpler way to do it. And here the difference is that we are using the Python slicing feature to reverse a string. This is slicing syntax in Python. And the slicing method starts from the end of the string with this -1 that indicates moving backwards and moves towards the beginning. Here we need to create a function that takes the full name, first and last name, split the name into two parts, reverse the order of the parts, and then join them back together with a space. Alright. And finally return the swapped name. Alright, so after taking a name as a parameter, then we split that input string into a list of words with this method split, separating them at spaces. So if the input is Jane Smith, after splitting, we are converting this input into this. And then we reverse the order of the list that we saved in this variable name parts. Remember, this syntax is a common Python slicing technique that reverses the order of a list or a string. So this indicates you're selecting all elements of the list, and -1 specifies the step or direction. A step of -1 means go backwards, so it reverses the list. And then the join method takes the reversed list and joins the element back together into a string with a space in between. Now we'll run it. And we get this result. Great. Another approach would be the key difference between the two approaches lies in how the names are reversed. In the first case we use the slice method, and in the second here we access the first name and the second element and swap them. But this method is less flexible if there were more than two names, but it's more straightforward for swapping exactly two names. So this exercise requires you to create a Python function that accepts a sentence as its input parameter, and the goal is to return the longest word found in the input sentence. So the function is defined with a single parameter, sentence, which is expected to be a string containing a sentence, as is here. And then we apply this split method on the sentence string, which splits the sentence into individual words based on white space, and this results in a list of words stored in the variable words. And then we initialize this variable longest word, which is initialized as an empty string, and this variable will be used to keep track of the longest word found during the iteration. And then we iterate through each word in the words list that we saved here, which allows the function to examine each word one by one. And then inside the loop with an if statement, we check if the length of the current word is greater than the length of the longest word. This length function is used to obtain the length of the strings. If the condition is true, it means that the current word is longer than the previously stored longest word. So longest word is updated to current word, right? And then we return this longest word. So let's try it. So the longest word is jump. There is another way to do it. Until here, as before, the split method is used to break the sentence into individual words, but then the different approach here is that we apply this max function to the words list that we save here, which takes first the words, the list as a first argument, and then key equal to len, which this argument tells the max function to find the word with the greatest length by using the len function as a key for comparison. Alright, and then directly it returns directly the word with the longest length, making the code more simpler. And we press play again, and the longest word is again jump. Alright, so here this exercise is about returning a new string with each character replaced by the next character in the character set or in the alphabet. That means for each letter detected in the input string, the function should return the letter that follows it in the alphabet. So for example, if the input string is A, we should return B, and here H will return I, E will return F. That means the function will take each character, determine its next character in the alphabet, and build a new string from these characters. Alright, so the function takes a string as input, and then we return a new string where each character is replaced by the next character in the alphabet. Alright, so we initialize an empty string that will store the new string as characters are processed one by one, and then we iterate over each character. The variable char represents the current character being processed in each iteration. And then within the for loop, the function or converts the current character being processed into its corresponding unique code, typically represented as a Unicode or ASCII value. So this assigns a unique number to characters typically used in English, and this OR function is a native Python function. It is used to return this code for a given character. And then by adding 1 to that value, we move to the next character in the alphabet. Alright? And then this char method is another built-in Python function that converts that numeric value back into its character representation. For example, if that method gets a char 98, it returns B. And then with result plus equal, we add the new character to the result string, which is the final result string, which contains all the modified characters. So let's try it now in the console. And we get that result, the same result. Another way to do it would be and this approach is cleaner for those familiar with Python. Here we use a generator expression with join, and we combine all characters directly into the result string. It's much more simpler because the generator does the looping and string building in a single line of code. In this exercise, we should return the smallest number in the list. Good. So first, we assume that the first element of the list is the smallest. Numbers would be the list we pass as parameter, and then we loop through the list comparing each number to the current smallest. And how we compare each number to the current smallest here with this if statement, where we simply say if a smaller number is found, then we update the smallest variable. And finally, the smallest number is returned. And here we have the corresponding results. Now let's try it with a much more simpler way to do it. Run it. Now here we obtain the same result by just directly calling this main function, which is another built-in function in Python, which takes an iterable and returns the smallest value found in that iterable. It's faster than manually iterating through the list and comparing values for understanding how programming logic works. Alright, so here, given a sorted array of integers, remove the duplicates. So we should group all the unique numbers and return them in the console. So first we check if the array is empty. If it is, we will return 0, because it means there are no elements to process. And then this function uses a variable that we called insert index that is initialized to 1, and its role is to keep track of where the next unique element will be placed in the array. Since the first element of the array is always considered unique, so the insert index starts at 1, meaning the next unique element found will be placed at position 1. Each time the function finds a new unique element, one that has not appeared before, it places this element in the position indicated by insert index. After placing the element, the function increases insert index by 1 to prepare for the next unique element, and this process continues until all elements of the array have been processed. Then we loop through the array, starting from the second element, index 1. Here, index 1. And then comparing each element to the previous one that we set by this -1. And if the current element is different from the previous one, meaning it's unique, the current element is placed at the position insert index, and the index is incremented. And after the loop finished, the function returns insert index, which represents the number of unique elements in the array. The array will have these unique elements group at the beginning. So as you see, the function ensures the unique elements are kept in order and duplicates are ignored. Here we have to get the last element of the list. The first approach will be to iterate through the list and return the last item. So first we pass the list we want to analyze as a parameter. Then we initialize a variable to none. This variable is like a starting point that provides a default value for last item before any elements are processed, and we set it to none just for clarity, because we indicate that the variable does not currently hold any meaningful data. And then with this for loop we iterate through each element in the list, and during each iteration we update last item with the current item, and after the loop completes, last item will hold the last element or the last item in the list, which is returned. Now let's try the function. So this function treats all elements as they are without distinguishing between types such as numbers, strings, booleans. The function processes each item equally and returns the last one in the list. Now let's try it with another approach. And here is an alternative way to obtain the same result. And here we calculate the last item by using this instruction that keeps the total number of elements -1, since indexing starts at 0 and the result is the same. Another approach would be and here the difference is just that we use the pop method, which removes the last element from the list and returns it. This method modifies the original list by removing the last item. But the difference here is that we alter the original list, right, by removing its last element. If you need to maintain the original list, you might want to use one of the previous method instead. Alright, so the goal here is to create a function that processes a list containing various data types, especially integers and strings. And the function should identify and extract only the integers from the list. And it will return a new list that includes all the integers while excluding any strings. Right, so the function takes the list as argument, and inside the function, directly in the return statement, we use a list comprehension used to create a new list with the new values. And in this part, we iterate through each element in the list, and the variable item represents the current element being examined. And then we use this conditional that checks whether the current item is of the type int, integer, and this isInstance function returns true if the item is an integer and false otherwise. And the first item indicates what will be added to the new list, while the second item in the loop is used to iterate through the element of the list. So let's run the function, and we get the numbers filtering out all the strings. In this exercise, we need to create a function that takes a dictionary and converts it into a list of key value pairs. So the key value pairs should not appear inside curly braces, but inside these square brackets that are typical of lists. So we start passing this dictionary as parameter, and then we define a list comprehension directly in the return statement. And with this dictionary.items, we get it's a method that returns all key value pairs of dictionaries as tuples, and the list comprehension converts each tuple into a list of key value. And then this sorted function sorts the resulting lists of lists based on the first element in each sublist. Run it, and here we get. In this exercise, we need to create a function that processes or go through a string and identify the vowels and sum their corresponding values. So we should basically return the total sum of the vowels values found in the string. It could be a string like this or like this. Alright? So the function takes one parameter, which is the string that will be analyzed. And then we define a dictionary that sets the numerical values assigned to each vowel. For example, A is worth 4 points, E is worth 3 points, etc. So by creating this dictionary, we can quickly look up the value for any vowel found in the input string, making the process more efficient. So instead of using multiple if statements to check each vowel and its corresponding value, we can store the values in a dictionary where each vowel acts as a key and its associated number acts as the value. And then we set this total variable to 0. This variable will hold the sum of the vowel values as the function processes the string. And then we iterate over each character in the string, converting it to uppercase to ensure case insensitivity. And this means lowercase characters will be treated the same as uppercase characters. And then we check if the current character is one of the defined vowels, and if it is, the corresponding value is added to total. Now let's start the function. So here we have 8 vowels, and in the second case we have 10 vowels. Another alternative would be it's another way to achieve the same functionality but using a different approach. This approach removes the need for a dictionary and use conditional statements if and else if to check the vowels and their respective values. The vowels O and U are ignored because their values are 0, so no addition occurs when they are encountered. So let's try. So in this exercise, the task is to create a function that takes a string and returns a new string with its letters organized in alphabetical order. So in the first example, Y is H at first because in alphabetical order H comes first, then N, and N comes first, then O. Right, so first we start converting the argument we pass here as a parameter into a list using this list method, which is like the split method in JavaScript. This allows for easier manipulation of the character. We save this new list that we created into this variable char list, and then the function we continue using a nested loop structure that implements a bubble sort algorithm that consists on an outer loop that iterates through each character in the list, and then an inner loop that compares each character with the next one. But what this inner loop first does is it controls how many times the inner loop will run during each iteration of the outer loop. It includes a range function that generates a sequence of numbers starting from 0 to the total numbers of characters in the list. And then this minus I reduces the range by the value of I, which is the current iteration count of the outer loop. This basically means that with each iteration of the outer loop, the inner loop will run one less time because of the largest element are moved to the correct position at the end of the list. Then within the inner loop, we check if the character at the current position j is greater than the character at the next position by applying this j plus 1. The comparison is based on the ASCII values of the characters. Remember, every character has their own code, and if the condition is true, it means that the characters are out of order, and in this case the two characters need to be swapped to maintain the ascending order, and this line performs the swap. So let's run the function and let's see what we get. Good. So a much more simpler way to do this. Here, just by using sorted, which is a native Python function that takes an iterable and returns a new list containing all the items from the iterable in ascending order. And if we apply this to a string, sorted treats the string as a sequence of characters, and it sorts this character based on their, remember, ASCII code, and in that way they arrange them in alphabetical order. And then we apply the join method that concatenates the items of the list that sorted returns into a single string, because sorted would return this output, for example, in this format with commas, and then join convert it into a string. So let's run the function and we get the same result. Alright, so this exercise involves creating a function that processes a list of books. This is a list of dictionaries representing books, each represented as a dictionary with a title and the number of pages. And the goal is to add a new property called length to each book. If a book has more than 30 pages, the length property should be set to long, and otherwise should set to short. And the function should return the updated list of books, including the new assigned length properties. So the expected output should look like this. Alright, this is a new property that should be added. So we take the books as parameters, and then we iterate over each dictionary book in the books list. Within the for loop, this if statement checks the number of pages, and with this condition then we determine whether the book is classified as long or short. And if the condition is true, the function adds a new key value pair, right? A new key value pair to the dictionary. And if the condition is false, we assign a different value short. The key part is here where we access the value associated with the key pages in the book dictionary. I don't want that you mess up the words. Dictionary in Python are like objects in JavaScript, right? These are dictionaries, and lists are arrays. And now let's print the result. And as you see, we get the new property that we add according to the function we just created. Another way to do it is more Pythonic. Now with this approach we use list comprehension, which categorizes books based on their page count. And if you look at the syntax, you see it's something like this. And this is what indicates that this is a list comprehension, which allows you to create a new list by iterating over an existing iterable, in this case books. So list comprehensions provides a simpler way to create lists. These square brackets indicates you are creating a new list, and this part of the loop is a loop that iterates over each item in the books list. And then this expression right here, this line, represents the expressions that constructs each new item dictionary in the resulting list. If you see this expression, indicates you are creating a new dictionary, and each item in the resulting list will be a dictionary. Then we have this unpacking operator that is used here to include all key value pairs from the existing book dictionary. It allows you to create all the properties of the book dictionary. Think it like we are copying the existing content we have here, and then we add, with this part, we add that new key value pair to the dictionary. The key length is the new property being added to the dictionary, and the value is determined by a conditional expression ternary operator that evaluates if the number of pages in the book is greater than 300. We assign long and otherwise short. Right. So let's now run the function to see if we get the same result. And we get the same result. Alright, so here the goal is to create a function that checks each student's graduation year. It looks at the starting year, and if it's after 1990, adds this student's name to a new list. And after going through all students, it returns the list of names who graduated after 1990. So the list of names the function will return are the students who meet the condition of being graduated after 1990. So the function takes an array of employee objects as parameter, which in Python is a list of dictionaries. Array of objects is in JavaScript. And each dictionary represents a student containing details such as name, graduation year. Then we initialize an empty list which will be used to store the names of students who graduated after 1990. And then we iterate over each student in the students list. For each student, it retrieves the graduation year. In this line, we extract the graduation year from a string and we convert it into an integer for further comparisons. And for that, we have to access the value associated with the key graduation year. But the value is expected to be a string that represents a range of year. That's why then we convert it to an integer. And then we apply the split method that is called on the graduation year string. This method splits the string into a list of substrings using this dash as delimiter. So for example, the graduation year would be this. Then the result of the split would be so we're splitting the string into a list. We're converting it into a list. And then with this 0 we are accessing the first element of the list resulting from that split. And in our example it would be 1992. And this is where then we convert it into an integer. And this conversion is necessary for numerical comparisons, and as comparisons between strings and integers would not yield the expected results, we do this conversion. Then we save that number in this variable here, and we do the evaluation we are looking for. If that year is greater than 1990, it means that that student graduated after 1990. So we send that name to the graduate list. And for that we should access the name of the student through in the same way we accessed before the graduation year. So to access the value associated with a specific key, graduation year in this case or names in this case, we should invoke the key. Right here we are invoking the key name and the graduation year. Remember, a dictionary in Python is a collection of key value pairs where each key is unique, and we have to use this syntax to access the value corresponding to that key. Now we'll run the function. So this student 1 and 3 are the ones who graduated after 1990, the other ones not. Another alternative would be the difference is that here we use the filter function to create a subset of students who graduated after 1990, right? The filter function is a built-in Python function that constructs an iterator from elements of an iterable, in this case students, for which a function returns true. And the first argument to filter is a function, in this case lambda, that defines the condition to be applied to each element in the iterable. And the second argument is the iterable to be filtered. Lambda student is like an anonymous function that takes a single parameter, student. This function will be applied to each element in the students list. And then the map function takes this filtered list and extracts the names of those students graduated after 1990. The map function is another native function in Python that applies a given function to all items in an iterable. Lambda again defines an anonymous function that takes one parameter, student, and inside that lambda function we access that value associated with the key name. This exercise consists on applying a 10% discount to each product's price. Right, so first we define a helper function called getDiscount. This function calculates the discount amount based on the given price and percentage. It takes two parameters, price, which is the original price of a product, and percentage, which represents the discount rate. In this case 10% is the discount. And the function calculates the discount by multiplying the price by the discount percentage divided by 100. And then apply discount is the main function. This function takes an array of product objects or products, a list of dictionaries in Python as input, and applies the discount to each product's price. For creating a new list of products with the updated price, we use a list comprehension, and in this line we create a new dictionary for each product with the updated price. We use the unpacking operator to create a new dictionary that includes all key value pairs from the existing product dictionary. It's like the spread operator in JavaScript. We copy the original product properties, and then we specify that the value for the key price will be updated based on the calculation, on this calculation, because here we call the getDiscount function, that is helper function, passing the current product's price and the discount percentage. The first argument is this one, price, the current product price, and the second argument, percentage, is 10, because as the exercise asks, we have to apply 10% discount. So this getDiscount function returns the discount amount, which is then subtracted with this minus from the original price, and this way we update the price. Then still inside the list comprehension, we use this loop that iterates over each item in the product list. So with this loop, we handle each product in the input list, applying the discount logic and constructing a new list of products with the updated prices. Let's apply the discount. Products, and we print this variable, updated products. And here we have all the prices with a 10% discount. To solve this problem, we need to extract the price which is inside these parentheses from each string in the list. Convert the price into a float and return the prices in a list, right? As indicates the exercise here, return a list of ticket prices in float format. So the function takes one argument, movie list, which is a list of strings where each string includes a movie title and a price in parentheses. For example, the matrix and this price within a parenthesis. Then we initialize an empty list to store the extracted prices from each movie, and then we iterate the list, and this is the core of the price extraction process. This movie splits the string at the $sign. This gives two parts, with the second part containing the price, and then with the number 1 we access that second part, which is the string with the price, right? Then the other split splits this part at the closing parenthesis, and with that 0 we extract just the price part, removing the closing parentheses. So remember, the string function is used to divide a string into parts based on a specified delimiter. In this case, in the first case, with this split $sign, we break this string into two parts at the $sign. So the first part would be this one, and the second part this one, and accesses the part number 1. We extract this part, the second part, isolating the other one, and the second split separates the string at the closing parenthesis, and by accessing this 0 we extract this part, and once we extract the price we convert it to a float with this float function and append it to the empty list process. And this way we collect all the prices from the movie list in a single list format. So let's run the function. And in the first example, the input is a single movie list sorry, is a single movie title, and the function successfully extracts the price from the string and returns a list containing the value, this value 12.5. In the second example, we have 3 movies, and the function processes each string extracting the prices. And so it does with the other example. Alright. So this exercise asks you to create a function in Python that performs an inner join on 2 lists of dictionaries. It should combine items from both lists based on a common key, just like in SQL or SQL. And the function will look for matching values of this key in both lists, and when a match is found, it merges the dictionaries into one. So the goal is to return a list with these combined results. Let's see the output, how it should look like. So as you see, the output represents the result of an inner join between these 2 lists based on the student ID key. Alright. So as you see, a student with student ID 103 and 4 are not included in the output because it's an inner join with which only keeps matching entries. Alright. Alright, so the function takes 3 parameters: the 2 lists that we want to join, and the key, which is the common key, a field that exists in both dictionaries to join them on, and is similar to a primary key in a database. And then we initialize an empty list to store the merged dictionaries, and then we start with the iteration, in this case through both lists. Alright. The first for loop iterates over each dictionary from students list, and the other loop for each dictionary in the scores list. And then with an if statement, we compare the key for each pair of dictionaries. It checks if the value of the specified key is the same in both dictionaries. So to access a value in a dictionary, we use these square brackets, and in that way we are accessing the value of a specific key within 2 different dictionaries, because previously we set a nested loop through which we then can access the value of both lists, right? And then within the if statement, if the key values match, it combines both dictionaries into a new dictionary. And that's with this syntax we merge both dictionaries. This is called the unpacking operator in Python, which takes all the key value pairs from a dictionary and spreads them out. It's like the spread operator in JavaScript. So in this case, it unpacks all the key value pairs from the students list and the other from scores list. Therefore, when you use this operator, you're creating a new dictionary that includes all the key value pairs from both lists. Python automatically combines both dictionaries into one. So if both lists contain the same key, the value from um, ob object 2 will overwrite the value from object 1 in the merged result. And then the merged dictionary is added to the result list, which is what we return in the end of the function. So let's run our function. And if we compare it to the expected result, it matched perfectly. Alright, so this is the turn of the left join operation we did before the inner join, and now the left join. So this exercise asks us to implement a left join operation in Python using two lists of dictionaries, and the goal here is to return all entries from the first list, which is the left list, and if there is a matching key in the second list, which is the right list, and combine their data. And this is the expected output. You see, if no match is found, the unmatched entries from the first list will still appear with fields from the second list set to none. So remember, left join is a method used to combine two tables based on a related column between them. In a left join, all records from the left table are included in the result set, along with matched records from the right table. Alright? If there is no match, the result will contain null or none in Python for the right table's columns, as you see here. Alright, so similarly to the other exercise, we start with a function that takes three parameters. The first one is the first list of dictionary, the left side in the join, and the other is the second list of the dictionary, the right side of in the join, and then the key, that is the key on which we perform the join. This key must exist in both dictionaries. Then we define again an empty result list that is created to store the merged dictionaries, and then we begin iterating through each dictionary in the first list, which is employees, and treating it as the left side of the join. And then we use this variable match found that is set to false, a boolean variable that is used as a flag to keep track of whether a matching entry has been found during the inner loop iteration, and it is initialized to false, indicating that at the start of each outer loop iteration we have not found any match yet. And then as the inner loop of the object 2 checks for a matching key with the current object 1, if a match is found, it evaluates to true. The code sets match found to true. So it basically helps to control the flow of the function, allowing it to differentiate between cases where a match is found and cases where it's not. And if a match is found, similarly to the other exercise, both dictionaries are merged using this unpacking operator and then added to result this variable, this empty list. The match found is set to true and the inner loop breaks. And then if no match is found in the second array, the function creates a new dictionary combining the object 1 with known values for any missing fields from array 2. This ensures all dictionaries from array 1 are included, even if there is no corresponding entry in array 2. And how the known values are set? Using this syntax, which generates a dictionary with keys from array 2, excluding the join key, assigning known to them. So let's run the function. In this exercise, we have to create a function that processes a list of freed dictionaries, each containing a name. The function should count and return a new list of objects where each object contains the freed name and its total count. And the output of the function would look like this. So this indicates the apple appears twice, banana 3 times, while orange and grapes once each in the original list. Alright? Alright, so as we are counting how many times each fruit appears in a given list, we take this list as a parameter and then we define an empty dictionary for counting. As you see, instead of defining an array to store results, we initialize an empty dictionary called fruit counts. Here, a dictionary is ideal because it allows us to store each fruit name as a key and the number of the occurrence as its value. In an array or list in Python, we can only store values in sequential order, and each item is accessed by its index. This means that arrays don't provide a direct way to associate specific keys like fruit names and with values like counts. And then we iterate over the list. We loop through each fruit object, and for every fruit we access its name and we assign it to the variable name. And then for each fruit name we check if it already exists in the dictionary. The get method returns the current count for that fruit name if it exists, or 0 if it does not exist. And then we increment the count by 1 and update the dictionary. And finally, in the return statement, we use a list comprehension to create a new list of dictionaries where each dictionary contains the fruit name and its count. Let's see what we get as a result. And here we get the result that corresponds to the output we expected. This exercise asks you to create a function that takes an argument and identifies the types of data passed to it, and the function will count how many of each data type are present, including integers, strings, booleans, lists, tuples, and dictionaries, right? And it then returns a list where each element represents the count of one specific type. In this order: first integers, then strings, booleans, lists, tuple, finally dictionaries. So the goal is to analyze the inputs and organize the results based on data types. Alright. So the function takes this argument that in Python is used to allow a function to accept a variable of number of arguments. So we can accept any number of arguments, not just a fixed number. This means the user can pass one argument or several arguments, and the function will still work without needing to specify the number beforehand. And since this exercise is about counting different data types using this expression, allows the function to check and count data types across multiple inputs, no matter how many are provided. And then we create 6 variables to keep track of the number of integers, strings, booleans, lists, tuples, and dictionaries found in the arguments. And then we iterate through the arguments with the for loop goes. The for loop goes through each argument passed to the function. It uses this isInstance function to check the data type of each argument. And if we go over with this loop, for each argument, if it matches a particular type, integer, strings, etc., the corresponding counter is incremented by 1. All thanks to this isInstance function. And finally, after all arguments have been processed, the function returns a list with the count for each data types in a specific order. Integers first, followed by strings, booleans, lists, tuples, and dictionaries. So let's run now our function. Alright, so this exercise requires creating a function to check the result of a tic-tac-toe game. The function looks at a 3x3 board filled with X for player 1, and O for player 2. It determines if one of the players has won, if the game is still going, or if it ended in a tie. And the function checks all rows, columns, and diagonals for free matching symbols. So the goal is to provide the correct status of the game based on the board's current state. This section of the code that we will use within the function defines all the possible winning combination for a tic-tac-toe game. It categorizes these combinations into 3 types: rows, columns, and diagonals. Within the rows, the first 3 sublists in this winning combination list represent the 3 horizontal rows of the tic-tac-toe board. Then we have the 3 sublists of the columns that represents the three vertical columns, and then the diagonals, the final two sublists that represent the two diagonal winning combination. So as you see, the first diagonal checks the positions from the top left to the bottom, while the second diagonal checks from the top right to the bottom left. So this winning combination list we will include in the function. Alright, so after defining all possible winning combinations, including rows, columns, and diagonals, then we continue with the flow where we check for a winner. So the function here loops through each combination and checks if all three positions in that combination contain the same character, either X or O, and are not empty, represented with this hash. So if a winning combination is found, it returns a message indicating whether player 1 with X or player 2 with O has won. And if there is no winner, it then checks if there aren't any empty spots left on the board, represented by this hash. If any are found, it returns game is still ongoing, indicating that the game has not finished yet. And if there are no winners and no empty spaces left on the board, it concludes that the game has ended in a tie and returns it's a tie. So let's try the function with these combinations. So as you see, in the first case, the function evaluates the board and finds that player 1, X with X, has formed a winning diagonal line with the position 0, 0, 0, 0, 1, 1, and alright. Therefore, the result is player 1 wins, because player 1 has successfully completed a winning combination. And in the second example, the function observes that player 2 with O has achieved a winning combination in the third column with the positions 0, 2, and 2, 2. Therefore, the result is player 2 wins, as they managed to complete their line before player 1. And in the example, there is no clear winner, since neither X nor O has completed a combination. In this exercise, we will create a function that sorts dates given in this format, right? This format represents the timestamp that combines date and time, date with day, month and year, and time, hours and minutes. And the function will handle both ascending and descending order, depending on the input, depending on what we pass on the input. All right. So notice that you don't need to import the date time as we did in other exercises. Even though we are working with dates, in this case we don't need to import that module because we are working by splitting the date string into its components and converting them into integers. So this approach does not require the datetime module. So the function takes a list of dates in this format and a sorting mode, ascending or descending. And in this case we have a helper function called dateKey, which is defined inside the main function sortDates. This is known as nested functions. This approach is used when the helper function is only used within the main function and does not require to be accessible anywhere else. Alright, so after we begin with the main function, we jump directly to the helper function, which is responsible for breaking down the date string into components: day, month, year, hour, minutes, just for sorting. Alright, so the helper function takes a parameter which is a string representing a date in this format, and then within the helper function this line splits the string that we took as a parameter into two parts based on the underscore that separates the date and time in the input format. So here we split the input string into two parts. The part before the underscore, which is the date, and the part after the underscore, which is the time, and the result is assigned to two variables, day and time. And then here we take the day and time strings that were extracted earlier here, and we break them down into their individual components. So here with this instruction we split the day string by their hyphen, turning it into a list like. Alright, so we split them by the hyphen, which is this symbol, and then with the map function we apply this integer to each element in the list, converting the string components into integers, so converting them this way. Then we do the same with the hour and minutes, but instead of taking this hyphen as the separator, we take this column, and then we convert them from strings into integers, and then we return a tuple to represent the date and time in a format that can be easily compared and sorted. This tuple ensures that the dates are sorted first by year, then by month, day, hour, and finally by minutes. And then with this sorted function from built-in Python function, which in the first argument it takes the list, which contains date strings formatted as this way, and sorts them based on specified criteria. And then in the second argument, the key parameter allows you to define a function that transforms each element of the list before sorting. This transformation is necessary because we want to compare the dates not as strings but numerical values. That's why we use the date key helper function that we defined earlier here. This function takes a date string and splits it into components, converting them into integers. And by converting them into a tuple of integers, as we explained here, we ensure that the dates are compared based on their chronological order rather than their string representation. And then this reverse allows the sort dates function, the main function, to function dynamically, determining the sorting order based on the value mode. This enables the function to handle both ascending and descending sorting easily based on the input provided by the user. So let's run the function. So when I execute this sort dates function with this input list and specify the sorting mode ascending, the function processes this list of date string and use the helper function to convert each date into a tuple of integers. And as a result, for example in the first case, the sorted output is reflects the correct chronological order in ascending fashion. The other one in descending and the other one in ascending. This exercise is about finding the longest substring within a given string, like this one. A given string of digits where the digits alternate between odd and even. And the task requires you to scan through the string and identify segments of digits that follow this alternating pattern. So simply the goal is to highlight sequence of numbers that switch between odd and even values. For example, in this case, it starts from here. So this sequence of the whole string includes an alternation, let's say alternation, between odd and even numbers. Remember, an odd digit is one that is not divisible by 2, like 1, 3, 5, 7, and 9, while an even digit is divisible by 2, like 0, 2, 4, 6, and 8. In the second example, the sequence is this one. Sorry, not here. So the challenge is to identify this sequence and return the longest one, as the exercise requires. Return the longest substring with alternating odd and even, or even and odd digits. If 2 or more substrings have the same length, return the substring that occurs first. So the function begins by initializing two variables, longest substring, to store the longest alternating substring found so far, and the current substring, which starts with the first character of the input string. And this basically sets up the current substring for comparison as we iterate through the string. And then we loop through the string, and for that we use a for loop that starts from the second character. Index 1 is the second character, and this is done because we will be comparing each digit to its predecessor, the previous one. And inside the loop we check if the current digit at the index I alternates with the previous digits at the index I minus 1. And this is done using the modules of operator. This expression gives the remainder when the current digit is divided by 2. And if it's different from the previous digit's remainder, they alternate. And one is odd and the other is even. And then we build the current substring. If the digits alternate, the current digit is appended to current substring. And if they don't alternate, the function compares the length of the current substring with the length of the longest substring. And if the current substring is longer, it updates the longest substring to the value current substring. And after checking the length, the current substring is reset to start a new substring from the current digit, since the alternation has been broken, right? And then we have a final check. After checking the length, not the length, sorry, after the loop, after this for loop, there is a final check to see if current substring is longer than longest substring. This is important because longest alternating substring could end at the last character of the string. And finally, the function returns the longest alternating substring found during the iteration. So now let's run the function, and the output matches the one we expected. Alright. In this exercise we have to find the next largest number that can be made by rearranging the digits of a given number that we pass as a parameter. So you need to look for a way to rearrange the digits, these digits, in such a way that the new number is bigger but still uses exactly the same digits. If there's no possibility to do that, because for example the digits are already in the highest possible order, then you simply return the original number itself. Right, so first we convert the number to a list of digits. The input number n is first converted into a string with this function string, and then the string is split into a list of individual digits as characters. This allows us to easily manipulate the digits. And then we calculate the total number of digits in the list that we stored here of digits, the digits variable, and this value is stored in the variable length, and it's used throughout the function to help iterate through the digits or to perform operations based on their position. And now here the goal is to find the first digit from the right that is smaller than the digit to its right. This is the point where the swap can occur to create a larger number. So this line here sets the variable I to the second to last index of the digit list. This is because the goal is to start checking from the end of the number, moving leftward to find the first pair of digits where the left one is smaller than the right one. By starting here, you are setting I to the index to the second to last digit, allowing the comparison between these two ones to begin from the rightmost part of the number. And then with this while loop, we try to identify the first decreasing point when moving from right to left through the list of digits. So with this condition, we make sure the loop does not go beyond the start of the list. So the loop continues as long as I is a valid index, starting from this second to last digit and moving left. And then we check if the digit at the index I is greater than or equal to the digit directly to its right, I minus 1. If so, it means the digits are still in non-increasing order, so the loop keeps moving left. And here we decrease the value of I by 1 with each iteration of the loop. The purpose of this line is to move left through the digits of the number. And then here we handle the case where no larger number can be formed using the digits of the n number. So this condition checks if the loop that was decreasing I has fully tried all possible indices without finding a digit that is smaller than the next one. In other words, it checks if all the digits are in descending order. So if the digits are already in descending order, no larger number can be created by rearranging the digits, right? So in this case, the function simply returns the original number, as the exercise asks here. And it returns the original number because it's already the largest possible combination of those digits. And now in the next step, this one, the goal is to find the smallest digit to the right of I that is larger than the digits that we are currently iterating over. And this ensures that after the swap, the resulting number will be as small as possible while still being larger than the original number. And here we perform the swap. This swaps the digit at index I, the first smaller digit found earlier, with the digit at index j, which is the smallest larger digit found after I. So this step starts forming the next larger number. And after the swap, here, the part of the number after index I is sorted in ascending order. This ensures that the new number is the smallest possible combination of the digits larger than the original number. And finally, the list of digits is converted back into a single integer and return it as the result. So let's try to run the function. In this exercise, we have to find the shortest subarray within a list of integers where the sum of its element is greater than a given number n, which in this case is this 9, 4, 1. So it's this number outside the square brackets. And with subarray we mean the portion of the array that satisfies the condition or the condition the exercise requires us. So for example, in the first example in this list, the shortest subarray or sublist whose sum exceeds 9 is 1 and 2, 5 and 8. The target sum is 9, and if we sum 5 with 8, it exceeds 9. In the second example, 3 minus 1 and 4 is the sublist whose sum exceeds or is greater than 4. So it's all about how many numbers from the list do I need to go through for their sum to exceed the number n, which is the one outside the square brackets. And why the result is 2 and 3 here? Because we have to count how many elements. We should return the length of that subarray, right? So we take two parameters, the list and the target number. Then we define a variable called left, which represents the starting point of the subarray that will be considered for summing. Then another variable that keeps track of the sum of the current subarray. And then we use this other variable to store the minimum length of any subarray whose sum exceeds the number of n. So initially it's set to infinity because we haven't found any valid subarrays yet, alright? So if no valid subarray is found, mean length remains as infinity, and therefore the function can check for this condition and return -1 as the exercise points out here. Alright. And then in the main loop, this right variable moves through the list to expand the subarray, and for each right index the corresponding value from list is added to current sum. And then within the for loop we define a while loop that handles the situation that as long as the sum of the current subarray, current sum, exceeds n, the function tries to minimize the subarray length by moving the left pointer to the right. And for each valid subarray, the one whose sum exceeds n, the length of the subarray, this length of the subarray, is compared with minimum length, and the smaller value is stored in minimum length. and then this value left is subtracted from the current sum, and the left is incremented to shrink the subarray to the left. And finally, if a valid subarray was found, the function returns the minimum length, which is the length of the shortest subarray. If no such subarray was found, the function returns -1. Now let's run the function to see if the values correspond to these ones we expected. Great. In this exercise, we have to take a list of elements and divide it into smaller groups of a specified size. Imagine you have a long list of numbers or items, and instead of dealing with all of them at once, you want to break them into smaller pieces. So the value n, that is the one outside the square brackets, tells us in how many chunks we have to divide the list. Alright, so if the number here is 2, we have to divide it in 2 parts. Here is again true in 2 parts, but as the exercise says here, ensuring that the last chunk can be smaller. It can be smaller than 2 elements only if there are not enough elements. So in this case, it can be divided in 3 chunks, only because the number 6 is a single element that cannot be added to this pair of chunks. That, and this example, in the third example, if the number 3 can be divided into 2 chunks, but with 3 elements each one. If the number 1 into 6 pieces, and so on. Alright. Alright, so we take as a parameter the list we want to split, and then the size of each chunk. Alright, so which is the number of elements in each sublist. And for resolving this exercise, we use list comprehension to generate the chunks, and this expression basically iterates through the list. In here we slice the list from index I to index I plus n, and then this loop generates values from I, which acts as the starting point for each slice, and the loop starts at 0 and increments by n each time. Alright, and it stops when it reaches the end of the list. So this range generates a sequence of numbers from 0 to the length of the list. For example, if n is equal to 2 and the list has 6 elements, this range will produce 0, 2, and 4, and these are the starting indices for each slice. If you run, in this exercise, you are given a list of student objects where each student has attributes such as their name, grade, and school, and the task here is to group these students based on a specific property like their grade or the school they attend. For example, if you choose to group by grade, all students with the same grade will be placed together in one group. On the other hand, if you group by school, students from the same school will be grouped together. These are the outputs. So the goal here is to organize the list of students into meaningful groups based on the chosen attribute. So the function takes two parameters, the list of dictionaries and where and a string property which represents the attribute of the group by, which is this case grade or school. And then we initialize an empty dictionary called grouped, and this dictionary will be used to store the grouped items based on the specified property grade or school. Each key in the dictionary will represent a unique value of the specified property, and the associated value will be a list of items that have that property value. So if the function iterates through the list of items, it will add entries to this grouped dictionary. And if an item's property value is not already a key in group, it will create a new key and initialize it with an empty list. Right, so then with this for loop, we iterate through the list of items, and for each item it checks the value of the specified property, and it then adds the item to the list associated with that property value in the group dictionary. And after going through the entire list, it returns that dictionary where each key is a unique value of the chosen property. So let's run the function and let's see if it matches the expected output. And you see it does without any problem.